right. Welcome everybody to Dagster's 11th, roughly every 2-monthly community meeting. Wave if you can hear me. Can you hear me? Yes, thank you. We've got a pretty packed agenda for you today. At the start of the agenda, I want to introduce Mollie, who is our new developer relations lead for Dagster. Mollie, will you hop on and say a couple words?
Yeah, hi. So I just joined Elementl. First day was yesterday, so very fresh. I'll be heading up the developer relations team. Previously, I worked as developer relations manager at Observable, as well as a data viz developer. Before that, a data visualization engineer at Netflix. And I also am the co-founder and events director of the Data Viz Society, so launched a big conference with them. Yeah, excited to be here.
Mollie's first day was yesterday, and we are ecstatic to have her on the team. Cool. I will give a brief 0.14.0 update, kind of whirlwind tour of what's coming in 2 weeks with our newest major release. Oh, and I'm Sandy, for those who don't know me. I am an engineer at Elementl. After that, David Laing from VMware is going to talk about monitoring-driven asset development and demo what he's been building and working on. And then Owen from Elementl is going to talk about software-defined assets and the modern data stack. All right, 0.14.0. Our target release date is less than 2 weeks from today, the Thursday after this coming Thursday. It includes, honestly, a ton of stuff. So when we talked about software-defined assets in our last community meeting, it was something like a demoable prototype. And if you're not familiar with software-defined assets, Owen's going to give a brief background and introduction in his talk. Since then, since our last community meeting, we've hardened the APIs considerably and introduced a rich new feature set, including partitioned assets, asset metadata, asset observations, tight integrations with modern data stack tools like dbt, Fivetran, and Airbyte. And in 0.14.0, we believe the APIs are ready for prime time and encourage you to try them out. So both David and Owen are going to be touching on this in their presentations. Dagit is going to have a new homepage. This homepage, which we've been affectionately calling the factory floor view or the job status view, will give you an overview of all the jobs that you have across your entire instance, including a fancy Gantt chart near the top, which helps you understand when these jobs are executing over time. Right now, you can turn this on as an experimental flag, and in 0.14.0, we're going to make it Dagit's default homepage. Another thing that I'm personally pretty excited about as someone who writes pipelines in Dagster is a new capability to allow logging op events without using yield. So if you're familiar with Dagster, this is what it looks like to sort of do the basic asset materialization. We expect you to have your op be a generator, and if you yield any sort of event, you also have to yield an output. With the new APIs that we are introducing, you'll be able to simply invoke context.logEvent and supply an asset materialization. So I think this has been requested for a long time. I think some people are going to find the ergonomics of this superior. Another of the top requests that we've received is the ability to make sensors and schedules on by default. So currently in Dagit, if you want to run a schedule, you have to go to the page for that schedule and manually click it on. With this new set of options, you'll basically be able to have a schedule or sensor running as soon as Dagit picks up the change, as soon as it's deployed. Dagit is going to be able to render table schema. So you'll be able to provide a set of column names, a set of column types, column constraints for a Dagster type or a software-defined asset. as a standard kind of metadata entry, similar to how you can include markdown or text or a float. And this is going to be rendered really beautifully in a bunch of different places inside Dagit. This gives you a sort of whole new level of ability to use Dagit as a tool for understanding what your data looks like and what it's supposed to look like. And more, which I don't have time to go through in detail, but we're going to have op selection in nested graphs, which is something that we've been sort of banging our heads against for probably years at this point. Johan on our team finally took it through the finish line. A bunch of performance improvements to make Dagit a lot snappier, and an integration with Airbyte, the popular ingest tool. So with that, I'm going to pass it over to Mr. David Laing, who's going to talk about monitoring-driven asset development.
Thank you, Sandy. All right. Yeah, so as Sandy mentioned, talking about monitoring-driven development, which is sort of a play on the ideas of test-driven development from the agile software development movement. So I think that in the data engineering space, we're kind of watching a set of paradigm shifts unfold. If you're like me, you probably started with a kind of project mindset. So you were thinking about projects where you were delivering some kind of data artifact, maybe a report to a stakeholder. There was always, they wanted some level of, some number of features by some specific date. We all know how that goes. And success was that your stakeholder accepted the data, artifact that you gave them, and then you moved on to the next project. Then I think as the automation tools started to mature, we moved to what I call the pipelines mindset. So we were basically using automation to do the manual steps that we had been doing before, but we still had something of a project mindset. We were just doing more automation when delivering that project. So we were still trying to deliver something automatically, but by a certain date. Success moved from acceptance by the stakeholder to your pipeline succeeding or not succeeding. And when you were finished, you moved on to making the next pipeline. And replay that cycle a couple of times, and I'm sure we've all had the experience where you have a whole bunch of pipelines, some of them are failing and no one's quite sure, who cares whether the failure is a problem or not. So I think that what's happening now, where I think lots of us are going and where Dagster is leading the way, is this shift from a project mindset to what I think of as a product, or perhaps an sort of data assets mindset. So instead of thinking about the pipeline that creates the asset, we shift the focus to instead talk about the actual data asset itself. We make that a first-class citizen. We talk about the data asset that our team maintains and that our stakeholders use for things like drawing those reports. And we shift into a sort of incremental delivery pattern where we get feedback and engagement from our stakeholders, and we use that to guide how we improve that data asset. We also shift, instead of having automation that's just used to create the asset, we also have automation that validates that the asset is available and has the quality criteria that our stakeholders expect. And only once we have all of that in place do we do the familiar work of creating pipelines to create the asset. And then we have a much more iterative approach where we look at, well, are our stakeholders asking for more data in this asset? Let's prioritize that work. Are our quality monitors showing us that the existing asset isn't being updated frequently enough, or that there's errors? Well, let's focus our attention on that. So to make that a little bit more concrete, in the Dagster world, in the pipelines asset, which we have been using pre version 13, our pipelines would look something along the lines of a pipeline is going to do some work, so do the daily work job, and it had a set of operations that we strung together very nicely, and those operations, some of them kind of some assets kind of like fell out of the bottom of this pipeline. But our focus was very much on building the pipeline. Is the pipeline succeeding? And I think that if we make that paradigm shift to thinking about assets, which the new features in Dagster 13 and now 14 help us to do, we can shift into much more of a sort of data product focused mindset, and we can start by publishing an MVP asset to the Dagster asset catalog and putting that front and center in front of our stakeholders to get feedback early on before we've even written any pipelines to generate that asset. Because as we all know, changes at this stage are significantly cheaper than changes later on in the process. We also can start by writing, and this is the kind of monitoring driven, start by writing the monitors that validate that our asset is some level of quality. And we expect it to fail in the beginning, but now we have something that we know once we've implemented some logic, we know when we're finished, because now these monitors are succeeding. It's also a great way to sort of demonstrate to our stakeholders why our data assets are trustworthy. We can sort of show them this is the automation that we have that validates that the data assets are good, and this is how frequently they're good and how frequently they're bad. And only at that stage do we get onto actually implementing the asset creation logic. So this is the traditional, create pipeline steps, but it's done in a way that we have a much clearer target, and we know when we've reached that target due to the previous two steps. And then we don't finish and move on to the next sort of project or pipeline. Now we think of Now we iterate on that asset. We get feedback from the stakeholders, from the automation, and we use that to prioritize adding more data, perhaps improving the quality, and so forth. And so success in this paradigm looks like a team owning some data products, some long-lived data assets with good quality and monitoring, and you always know, what's important to the team, where you should focus your attention. All right, that's lots of theory. Let me show you some code. So this, I hope, will be merged into the standard set of examples once this pull request gets merged under the monitoring-driven software-defined assets example. So first step here, publish the MVP asset to get some early stakeholder feedback. So we want the simplest possible thing that we can write in Dagster. We want to write some logic to validate the properties of that asset, and then we can even use the same validation graph in to sort of drive our acceptance tests while we're developing. So let me show you what that looks like. Right, so what I have here is a very simple implementation of a Dagster asset. Up here is its schema, and down here is the definition of the asset and conforming to that schema. And when I load this up inside Dagit, whoopsie. Come on, there we go, mouse control, there we go. All right, so have a look at this. So we want to kind of publish this this very basic asset schema with no actual data in it yet into our asset catalog and get our stakeholders engaged about, is this the thing that they were expecting? Is this the definition when they talk about a customer being active, for example? Is this data that's presenting helpful for them? How are we going to partition keeping this thing up to date? So here we've kind of arbitrarily chosen daily, but maybe that's a wrong thing. We can get them used to the idea that, as automation runs, they can come back to this asset catalog page to see this, the state of the data asset. So here we go. So we filled in one partition, and here we go. We can see that one of the 6 partitions is now filled with some test data. But more importantly than that, we can also start showing them how we're going to validate the quality of this data. So in this case, the implementation that I did was the simplest possible thing. I just I made a view in my data mart with some static data in it. So it just happens to work for that date, but obviously it won't work for any future dates. So I can write a Dagster pipeline that is focused not so much on the creation of the data, but on the validation of the data that's in the mart. And so I can have a set of graphs around validating specific data assets, and within those they can have a particular set of conditions. So it should conform to some schema, it should contain perhaps some current date, and then the actual implementation of these is, so here's an implementation of one of those validation operations. It should contain current data, and this is just, you can put whatever logic you wish in here to validate whatever the thing that you're validating is. But the key is that by yielding an asset observation, you can link the result of this test back to the actual asset in the asset catalog. So let's show that in action. So I'm going to oops, I should probably do that for one of the days we actually have data. And so this just looks like a regular Dagster pipeline, but instead of it having steps that create data, it's actually got steps that validate the data. And then because I'm raising asset observations, we can see that this one conforms to the schema. I was expecting one of these to be a failure. But if something went wrong in the asset validation, then it would show up here as a problem against this particular partition, and you could see what the cause of that problem was. Oh, and then finally, I mentioned that we can use that this same job that we ran manually over here, and that we can use Dagster's scheduling capabilities to run for us automatically. We can run that same job, but kind of in a PyTest context, to help drive our actual implementation development. So I'm using the PyTest parameterize feature to just check to execute this this monitoring job and then validate that all of the steps succeed. So now I get a set of unit tests that I can use to guide my development implementation. So, for example, it should conform to the schema step worked, but it should contain current data didn't work. So I get a nice helpful error that helps me when I'm doing my implementation. All right, so that's phase 1. Just to recap, so we talked about publishing the asset as one of the first things that you do in the asset catalog, and what we're trying to do is get early feedback from our stakeholders and trigger the kind of questions that sort of come up. Can you actually access this location in the data mart? It's a big one I bump into a lot. The perennial, oh, what do you mean when you say a customer? Especially if you're in a corporate environment, is a customer the subsidiary or the parent company or the one that pays the bills? And you can have conversations about the required grain. We've assumed daily here. Maybe actually this is something that needs to be done hourly, or maybe it's much slower. Maybe we just need something quarterly. But having those conversations early on can really impact how you go about implementing things. Then we talked about writing a validation job, where each operation is a check for the data quality as opposed to something that makes data, and using the asset observation type to kind of link that metadata from the validation run into your into the asset catalog. And then finally, using the same validation pipeline but run inside a unit test context to serve as your acceptance test while you're implementing the features. All right, phase 2. Now that you have set the stage, now it's time to get on to the bit that used to be step 1, which is actually developing the logic to put the asset in the right place. So what I think we should be doing under this paradigm is to first deploy our monitoring and see that it's failing in a way that we expect. Are the error messages we see in the monitoring helpful? Do they tell us which environment, for example, the failure is occurring on? And then we just need to implement the simplest first thing to sort of pass the validation that we have running. Simpler is better is always my approach. And maybe we begin just by having some manual steps. Maybe we don't have a fully automated process in the beginning because we're still learning about the problem that we want to automate. You can't automate something you don't understand. And you definitely don't want to be doing things like worrying about performance optimizations or any of those. Those are things, once this asset is used and important, that's the time to invest in that, not at this early stage. And then finally, we can use the monitoring and the associated acceptance test to tell us when our implementation is good enough. Looking at the time, I'm going to skip over the phase 2 demo, but let me just show you sort of by the recap. So you would have deployed your monitoring and it would have failed for some amount of time, and then finally once you deployed your implementation that worked, now you would have started to have your monitoring starting to succeed. Your first implementation can be really simple. Perhaps rather than doing a whole lot of logic to compute the daily information, you just do that manually and stick it in a CSV or a spreadsheet and have that be imported. Whatever is the simplest thing to get data in front of your stakeholders, data that passes the quality monitoring. And then phase 3 is to iterate on your solution and to prioritize where you focus based on the feedback that you're getting from your stakeholders. Are they asking for more data? Are they asking for a different schema? Is the update schedule, maybe they want to change that? Or your automated asset monitoring. Are we finding that things fail on Monday mornings because the systems are overloaded? Maybe we need to implement some retry logic. Are we finding upstream data quality issues? And maybe you in fact get no feedback at all. And that's probably a signal that perhaps people don't really care about this thing that you thought was an asset, and you can focus your attention on something else instead. Some further ideas. You could add notifications based on the monitoring job to let you know about problems before your stakeholders notice them. There's no reason that your monitoring job should only be limited to monitoring your assets. As we saw, the monitoring operations are just a Python function. You can do whatever you like in them. Maybe there's a set of upstream assets that you depend on that would be helpful to monitor. Or maybe you want to monitor something downstream. Is the data that you're producing that someone is copying into an S3 bucket, is it getting there without being corrupted? That'd be something that you could monitor as well. And then finally, you can start to use the monitoring as the beginnings of some kind of data service level agreement with your stakeholders. You might say something like, a particular data asset will be stale no more than 10 days per quarter, for example. And you have a nice measuring system because the days when your monitors failed are the days when that asset was stale. So to sort of visualize that, we've got here's our monitoring system running. We're running it on a schedule, and I think this is quite subtle, but I think important. You want to pick a schedule that's relevant to your stakeholders, which doesn't necessarily have to be the same schedule as the automation that creates the asset runs on. Maybe that runs in the middle of the night, but your stakeholders tend to sort of check their reports or refresh their reports first thing in the morning. So let's run some validation that the asset is still available and correct at about the time when they're about to look at it. We talked about adding alerts so that you can notice when there's a problem before your stakeholder calls you in a panic. And we talked about how we've got a very simple way. So assuming that we're running our validation functions using partitioning, we can use the partitions view to sort of see which days it was successful and which days it was unsuccessful, and our SLA can become something simple like no more than a certain number of red dots every quarter. All right, so recapping. So we talked about this whole idea of monitoring driven development is part of this paradigm shift that we're seeing and that Dagster is helping to drive, this move away from pipelines and towards assets. And the approach that you follow is you start by publishing information about the asset upfront so you can get stakeholder feedback nice and early. You can try drive that in engagement, and you can make changes when it's cheapest to make changes. You use your Dagster pipelines to actually drive asset monitoring. And we're testing the quality of our assets from the stakeholder perspective, not necessarily from the producer's perspective. And we're verifying, we're asking our stakeholders to place trust in our data assets, so we should have a mechanism of verifying why they should give us that trust. And it's only once you've done steps 1 and 2 that you get to what used to be step 1, which is to actually implement the asset creation logic. But you've got a nice set of guides to tell you what you're aiming for and when you're there, when when the monitoring job starts to pass. And then instead of finishing and moving on to the next project, now we iterate to try and make this asset better. Where based on feedback, we add more data, or maybe we improve the quality or the reliability of something. And success in this new paradigm looks like a team that has a bunch of long-lived data assets with a well-known quality, some kind of SLI driven by our monitoring, and then we're thinking about selling the same assets to additional stakeholders rather than being on the perpetual treadmill of just doing the next project. And that's it. I'm not sure about timing. If there are questions, please just add them to the Zoom chat, and I'll answer them, and I'll stick around at the end to answer questions as well.
Thank you, David. That was fantastic.
Thank you.
Also, just wanted to say I love your SQL shirt. Didn't catch that until the end.
Yeah.
Cool. Yeah. So pop questions in the chat, and David will answer them there, and then at the end we'll have a few minutes left for questions. Owen, take it away.
All right. Well, once the pinwheel of death goes away, maybe I'll be able to present a little better. But yeah, thanks, David, for introducing some of these concepts. I'm still gonna go over and do sort of a high-level recap of some of the stuff David was talking about before I jump into a demo. And this demo is going to focus on how these software-defined assets and these concepts relate to some more external tools. So whereas David's content was focused on how you can create these assets using Python, there are also external tools that you might want to interface in which you define your own assets. So in particular, this demo is going to go over Airbyte and dbt, but there are a bunch of other tools that these same concepts would apply to. All right. So yeah, the high-level goal here is to expose interfaces that allow you to think more about the assets that you want to produce rather than the tasks that you want to run. So as David showed, assets are essentially just products that your data platform is producing. Any sort of persistent thing that you might want to refer back to after a job completes. So the classic example is, of course, a table in a database, but this can also be a little bit more general, something like a machine learning model, or a report, a dashboard, that sort of thing. And these are often sort of the entire point of writing a job. You don't necessarily care about arranging tasks in a particular way just for fun. You care about it so that you can produce a particular thing in a particular way. However, traditionally, working with assets can be kind of difficult. Deploying changes can feel dangerous or irreversible. After you push a change, it can be hard to know what other downstream assets need to be updated as well. If you push code that has a bug in it or otherwise mysterious error, fixing this may involve tedious backfills that may have to be kicked off manually or even have unknown knock-on effects. Performing operations often requires mentally translating between assets and tasks. Understanding how to refresh a particular asset requires that you know what task produced that asset and what tasks are relevant to that downstream task. Understanding when an asset will be updated similarly requires understanding when a task will be updated and then translating that back to the asset layer. All these issues culminate in a problem where assets are difficult to trust. Knowing if something is up to date or was created with the right version of code is often challenging or even impossible given a particular tool set. We believe that orchestrators are in a unique position to help with these issues. As long as the orchestrator can know what asset a task will produce, they can know if an asset is up to date simply by inspecting when a task was run. In addition, they know how an asset is generated, which means that you can kick off computation to regenerate that asset at a particular point in time. After all, the orchestrator is the natural execution plane for all of your data products across your platform. Similarly, because an orchestrator needs to know the dependency between tasks in order to function, they also, by extension, can know the dependencies between assets. However, traditional orchestrators often are completely ignorant of the assets that a task will produce. So they may know all these different dependency links between different tasks. They may know when a task is set to run, but they don't have any insight onto the actual point of those tasks. We believe that this is a huge opportunity for orchestrators to actually expose the underlying purpose of a job. Okay. So with that sort of high level overview out of the way, I'm going to demo a particular incarnation of software-defined assets. In this case, integrating with external tools in which the user defines particular assets. So the high level goal is to take data from some online transactional database, put it in a data warehouse, and then once it's in the warehouse, do transformation on it. And the tool we're going to use to move data from point A to point B is Airbyte, which is akin to Fivetran if you're not familiar with Airbyte. And the tool we're going to use to transform data once it's in the warehouse is going to be dbt. So before I get into the Dagster view of these things, I'm going to show you the actual tools and what they look like. So this is Airbyte. Airbyte, like Fivetran, allows you to specify a set of sources. This is the particular source that's important for this demo. It's a Postgres database that in demo land is some online transactional thing. In reality, to peel back the curtain, this is just some Postgres database running on my local machine. You connect sources with destinations. In this case, I have a single destination called Postgres replica. In real life, this would probably be a database that's more suited to analytical workloads like Snowflake. But again, this is just a different database running on my local machine. You connect sources to destinations, and this allows Airbyte to take data from point A to point B. If we look into this particular connection and at the settings, we can see here that there are 3 tables that I've selected to be replicated over. So event logs, organizations, and runs. And if you think about what I've done here, I've kind of just defined 3 assets. So I've defined these 3 data assets that I expect Airbyte to manage for me. I expect it to be able to take data from someplace and create this data asset in my replica database, event logs, and then this one for organizations, et cetera. So I've defined 3 assets here in Airbyte. And in DBT, similarly, I imagine a lot of people are familiar with DBT, but if you're not, a gross simplification is that it's a SQL templating tool that allows you to create SQL models that do transformations which reference other SQL models. So inside a single DBT project, you can get a whole web of interconnected models. So I've done that here, and this is what that looks like in DBT land. So this is all just using DBT as usual. And you can see these 3 green boxes are the sources that we're using. So these are the tables in the replicated database, organizations, runs, event logs. And then information from these tables is queried, joined, meshed together into a set of, once again, data assets. So these are all tables in a database that an analyst might be interested in or curious about or want to refer back to. And now if we go into Dagster and look at a sort of traditional task-oriented view of what's going on here, we see that there are just 2 steps. The first step is to take data out of the source database, put it in the data warehouse, and that's accomplished with a single Airbyte sync operation. And the second step is once it's there, we want to transform that data using our DBT project. So DBT will run and compute all those assets. However, as I mentioned before, while this is a useful view and completely accurate to the operational workload that we're running, this is not necessarily the only view that we might care about. After all, inside of DBT, we have all this rich information about all the assets produced. And similarly, inside of Airbyte, we have this information about the assets that are produced. So I'm going to flip a switch and give us a different view of the same operational graph. So again, this is still just the same exact job. It still has 2 steps. The first step is to run Airbyte, second step to run DBT. But here we see a rich, detailed view of the interconnectedness between all of these different assets. So for example, we can see here that this runs annotated DBT model depends on these runs and organizations tables that are created using Airbyte. Then if I click rematerialize all, this will kick off a run of this job. And you can see, once again, the job just has 2 steps. And this will take a little bit to run. But if I come back to the job, we can see we already get some operational information about what's going on. So while this run is kicking off, we can see right here on this asset view that a run is currently rematerializing this particular asset. So we get the spinner. Similarly, if I click on this, we get a link to that particular run, as well as some metadata about the last time this was run. So for example, we can know what columns were there, and there's other metadata that you can optionally attach if you're interested. Here's the run going. Similarly, this DBT step now knows that a run has started that will soon rematerialize this asset. This step isn't running yet, which is why it doesn't have the spinner. And you can imagine, while this is already useful for a quick running task, you can imagine a world in which these syncs take a significantly longer amount of time, 30 minutes, an hour. And this gives you a really clear view into the exact state of everything that's happening. So the Airbyte sync just completed, and now Dagster knows that, hey, the upstream of this asset, as well as everything up here, has updated more recently than this asset has. So that means that there's probably new data there that this model has not taken into account. So we get this little upstream changed flag, and that'll go away as soon as this DBT run completes. So this is an extremely powerful operational view already that gives you detailed information about all of the assets and their state in your system. For example, if you're curious about if you're working on this steps annotated model, you know for a fact that daily step stats depends on it, and therefore if you change it, daily step stats might need to change. This is something that DBT can already tell you in the tool, but what DBT can't tell you is that if you remove a column from event logs, then you probably want to also update the steps annotated model to take that into account. You get this very quick cross-dependency or cross-technology dependency structure. You can also imagine if you defined another Python asset, just some random Python code that consumes this event logs, maybe it does some bot filtering or something, this would also show up here. So again, if you're working on this event logs thing, it's very quick to determine what effect changing this will have. Similarly, it's not always the case that this is the view you're interested in. Sometimes if you're an analyst, say, and you don't particularly know that a particular asset lives in this job, you might just want to search directly for something that you work with every day and know about. So for example, I might be an analyst that works with the step stats table, and I can just search for that directly and be brought to this page in the asset catalog. Here, not only do you see the most recent materialization information and whatever metadata that DBT has decided to include on it, but you also see a historical record of every single time this has ever been materialized. So if you're debugging, you can always go and click into the particular run that generated this particular materialization, which is an extremely powerful debugging tool. You can also see upstream assets and downstream assets and page through from this view. In addition, if you're working on the step stats model, you can directly kick off runs of this or rematerialize this particular asset from this page directly. And showing that from this view, if I go here to the step stats model, I can show off a particular DBT specific integration that we've included in this. And I'll answer some of these questions at the end. So with DBT, while it is true that a single operation is responsible for updating the entire DBT graph, sometimes if you're updating something near the tail of the graph, it isn't necessary to run through all these potentially expensive computations in order to just refresh a single model. So for example, if I was working on the step stats model and I updated it, what you can do is launch a run that materializes only that model. And what this does is it sort of sinks down to the DBT layer and modifies the actual DBT command that's being run in order to run just that single model rather than running everything at once. So if you're familiar with DBT, this select parameter gets added in, and instead of running all 9 models as it would in a usual run, it'll just run a single one and produce a single asset materialization. So if we go back here, we can see that none of these other models have had their upstreams changed, but this usage stat model has now recognized that, hey, step stats has been run more recently than I have. If there's new data there, I probably need to be rerun. So to reiterate, the idea here is that a lot of these modern data stack technologies, your ingest tool, your transformation tool like DBT, are in essence ways to define assets. Dagster doesn't need to know the exact computations, like down to the source code that are being run. All it needs to know is that, hey, this operation will produce these assets. And when you expose that information to your orchestrator, you get a ton of value unlocked. So for example, if you compare this use case where I want to know, hey, like what event or what effect will modifying this particular asset have, if you try to answer that question purely with the tasks, you really can't do it. All you know is that something in Airbyte happens and then something in DBT happens. But by exposing this sort of rich operational information, you get a really detailed view into the reality of the complexity of your data platform. So that is the demo. I'm happy to answer questions. But yeah. So one of the questions was, what kind of metadata do you pull from Airbyte and DBT into Dagster? So right now, Airbyte exposes schema information. So that will align with the stuff that Sandy was showing right at the beginning, where you can get that rich table schema metadata attached to every single asset materialization. As for DBT, you saw a lot of the metadata pulled there. That's just directly from the DBT output. There's also the functionality exposed to add a custom runtime metadata function, which will take, that can basically be an arbitrary Python or set of Python code that you run for each DBT model to add, for example, like row count, et cetera, onto there. And then there's a question, is there a way to modify the DBT command that is being run when an upstream model is changed? Right now, the full refresh and options like that are not exposed, but I don't see a particular reason why that would be impossible. Yeah. We expose ways to modify the flags at the resource level. So you could definitely do it through the run config. But right now there's not like an automated way to inject that. Like we don't detect if something's an incremental model or not.
And maybe I missed it, but Owen, did you answer Pratik's question about if someone rematerializes a specific asset, does Dagster do any work to decide which parent assets to rematerialize? I can also take that one.
Yeah, go for it.
Yeah, I mean, I think the short answer to this is that you can use Dagster's existing schedule and sensor abstractions to sort of build as complex logic here as you want. So the step one might be to define a asset job, which is essentially a selection of assets that you want to all execute at the same time. That includes, not just that particular asset, but also the upstream DBT and Airbyte assets that you want to rematerialize at the same time. And then to put that job on a sensor to make it trigger at the time that that's most relevant to your workload.
That makes sense. So I'm guessing Dagster gives you the abstractions that maybe say something like, if this upstream asset was last refreshed more than X hours ago, then I'm going to write some code to make sure I refresh that first.
Yeah, I think we probably, it might be a little hairy at this point, but that's something we want to make kind of very easy very soon.
Got it. Thanks.
So I'm going to sort of give it a couple of minutes of silence just to see if anybody has additional questions that pop up. I know sometimes it can take a while, and feel free to ask questions both about what Owen showed off and also about what David was talking about. We'll go ahead until the 55 mark. David, I had a question for you actually, which was you talked about those 3 stages of sort of development from like project-based, the pipeline-based, to asset-based. I'm curious, like, what did monitoring look like for you in the project-based phase? Like, was there like absolutely no monitoring? Was there ad hoc monitoring?
There was stakeholders shouting at you monitoring.
Mm-hmm.
Yeah, I mean, in my experience in the project-based, it's all about to deliver a certain amount of thing by a certain date, you're obviously late, so you cut scope, you deliver the best, the best that you could do, and then it's on to the next thing. There's never any monitoring. There's just stakeholders that are upset, and there isn't anybody who really remembers, how it was supposed to work. They've moved on to different projects. So I think, part of the idea is this notion of data becoming a product with a team that knows all about that, the data asset product, and cares about it and monitors it and, detects problems before the stakeholders.
Oh yeah, sorry. I can show the code for the Airbyte DBT demo. I completely forgot to do that. Let me share my screen again. So this is what it looks like. The Airbyte integration is not in open source at the moment. It will be by 0.14.0. But the basic idea is, for DBT, it's really easy to generate all of the assets just because DBT contains all the metadata that we need to generate the dependency information. For Airbyte, we just put in an explicit list of the table names that we expect. And then from there, at runtime, we can call the Airbyte API to verify that everything is looking like we expect it to. And we just pass in a connection ID so it knows which connector to sync. And then from there, it's just purely this build asset job function where we take a list of the assets that we care about. So our Airbyte assets and our DBT assets, and then just normal Dagster resources to talk to the relevant APIs. But yeah, you don't have to specify dependencies between these. The reason that it knows to run DBT after Airbyte is simply that there are DBT assets that depend on Airbyte assets.
All right, with that, I think that is the end of our, we have one more question from Asaf Lavi. I'm just gonna read it out loud. Are there plans to implement something like Kubernetes liveness/readiness pro APIs for software-defined assets, kind of formalizing some of the stuff that David discussed, like a monitoring job as official Dagster APIs? Asaf, would you mind telling me a little bit more about what that would look like, what like a liveness or readiness probe API would look like? Would you essentially, go ahead, yeah.
Yeah, it kind of ties both talks together. Like if you could think of like DBT has tests, like a concept of tests as part of the data model there. So if you can tie that as a quality check of a data asset, like even deepen the integration between Dagster and DBT as an example, and use test results to kind of surface data asset health in the graph that's in DAG.
Got it. And in terms of consuming that health, are you imagining consuming that like just like via Dagit, or actually via some sort of something that downstream jobs could look at?
Yeah. So Dagit, as a starting point, can propose, maybe you should rematerialize this because this data asset is stale according to its own tests.
Got it.
Yeah.
Cool. Yeah. I mean, I think we are definitely very interested in offering the ability to have kind of like first class asset tests or like asset quality checks, arbitrary code that users can write that looks at an asset and determines whether something is wrong or not. And so then I think what that would probably look like for us to complete the circle would be to connect those to sensors. So allow you to look at the results of those tests inside of a sensor evaluation to figure out what to launch next.
Great. Yeah, that makes sense.
As well as make it easy to consume what's going on in the UI.
In my demo, I was linking the two things with the asset observation, which from a user's perspective just felt like I was essentially attaching some additional arbitrary metadata to an asset key. So presumably that that pattern will continue?
Right. It would likely live on the asset observation, something that allows you to sort of log as an event what you're seeing about a particular asset. Any other questions before we wrap up? All right, thanks everyone so much for attending. Our next community meeting will be roughly 2 months from today. We'll send out the date and calendar invite. Take care.